Hello and welcome to the second lesson of Module 11. We're going to solve quadratic equations by graphing. So I can graph a quadratic function and then use the graph to find the solutions of the equation. So let's recap real quick what we talked about in the first couple videos, the 5 key features of a quadratic. 1, standard form, we've used it a lot. The shape is a parabola, it's a U shape. The axis of symmetry cuts the parabola in half, and it has a formula attached to it. We found the vertex. We did all of that in the first lesson. Now we're going to take a look at the fifth and final key feature that we listed, and that is intercepts. Intercepts are where the parabola crosses the x or the y axis. So the y-intercept, see it down there at the bottom in blue, is where it crosses the y-axis. You've done that with lines. We've done that with exponential graphs. Now we're doing it with parabolas. Okay, that's just the starting value. It's when x equals 0. All right. Notice it's not always the vertex. In this case, the vertex is not on the y-axis. The y-intercept really doesn't tell us much. The x-intercepts, though, the ones in red there, those we're going to be finding quite a bit. Those are the solutions to a quadratic equation. The x-intercepts are the solutions. They are the same thing. So if a parabola crosses the x-axis twice, it has 2 x-intercepts or 2 solutions. If it just touches the x-axis and turns around, if the vertex is on the x-axis, it has 1 x-intercept or 1 solution. It can also have the situation where it never crosses the x-axis. Then it would be not a real number. So no real solutions. So we're going to graph these. We haven't actually done this yet, but we've done enough to get us moving with this. So here's a table. You're going to be using that. Write that down in your notes. If you need to pause, do that. You'll notice the table is empty. Okay. First of all, let's make sure we understand what this is going to look like. It's going to open up or down. It's going to open up because the A value is positive. It's positive 2. Okay. The A value is 2. The B value is 4. The C value is -1. Let's go ahead and find the middle of the parabola. Now, this is important. A lot of times when we did tables of values, we put -2, -1, 0, 1, and 2 in the x coordinate or the x values. We're not going to do that here because we want to find the middle of our parabola first. And that's what we're doing when we find the axis of symmetry. So we're going to use the formula. We did this in lesson 1. You go back, go ahead and do that. -4 over 2 times 2. -4 over 4 is -1. So x equals -1 is my axis of symmetry. I'm going to put that on the graph. So that red dotted line that just showed up on the graph, that is my axis of symmetry. That's where the parabola is going to go around. Okay. It's also where I'm going to put I'm also going to put that in the middle of my table. So my x value of -1 is going to go in the middle of my table. Now from there, I'm going to find 2 numbers bigger than -1, so 0 and 1, and 2 numbers smaller, so -2 and -3. Now, how do I find the y values? I just plug them in. So -3, I put it in for x, so -3 squared. I'm going to talk through this. I'm not going to have it show up because that would be a lot of stuff on this slide. You're putting -3 in for x. -3 squared is 9. 2 times 9 is 18. 4 times -3 is -12. So 18 plus -12 is 6. 6 minus 1 is 5, and that's where the 5 comes from. -2 squared is 4. 4 times 2 is 8. 4 times -2 is -8, so 8 and -8 makes 0. 0 minus 1 is -1. If I put -1 in, -1 squared is 1. 2 times 1 is 2. 4 times -1 is -4. So 2 plus -4 is -2. -2 minus 1 is -3. 0 should be really easy. 0 is going to cancel 2x squared. It's going to cancel 4x because 0 times anything is 0. It's just going to be -1. And then 1 squared is 1. 2 times 1 is 2. 4 times 1 is 6. So 2 plus 6, sorry, 4 times 1 is 4. 2 plus 4 is 6. I'm getting ahead of myself. 6 minus 1 is 5. Now, I want you to look real quick before we go any further. Look at the symmetry that's happening. The middle of the parabola is at -1. If I go one step smaller to -2, the y value is -1. If I go one step bigger than -1, one step bigger than the middle to 0, the y value is also -1. It's because of that symmetry. Now we're going to plot the points. -3, 5, -2, -1, -1, -3, 0, -1, and 1, 5. And connect those points to make your parabola. Notice the vertex is there at the bottom at -1, -3. Is that vertex a maximum value or a minimum value? It is a minimum value. It's at the bottom of the parabola. The y-intercept is at -1, so 0, -1. The x-intercepts are the solutions. Those are the values that are going to give me 0 for y. Circle them on the graph. So they're right there. They're not good numbers. I don't have good numbers solutions here, but it crosses the x-axis twice. Those are both solutions. Okay, so here's another problem. I want you to pause the video. I want you to try to do those 5 parts down there. Does this open up or down? What are the A values, B value, C value? What's the axis of symmetry? What's the vertex? Is that vertex at the top or at the bottom? And then what are the x-intercepts? Okay. Hopefully you see that I can tell a lot of this stuff just by looking at it. This is going to open down because the A value is negative. The vertex, because of it opening down, is going to be a maximum. The vertex is going to be at the top. Okay, so those are a couple things you can tell without even graphing. Now, this all shows up at one time, but let's go through it real quick. This opens down, like I said, A is negative. If I plug in the numbers for the axis of symmetry, that's what I got to do. -8 over 2 times -2, so that's bottom becomes -4, so -8 divided by -4 is +2. You see the red line go there. So the vertex is 2. Look at the table. 2 numbers smaller, so 1 and 0. 2 numbers bigger, 3 and 4. Okay, plug those numbers in to get the y values, plot the points. Okay, so the x-intercepts actually are numbers that we can spot this time. They're 1 and 3. Let's circle them. Those are my solutions. All right, so that's graphing. A real quick synopsis. Remember, you can have 2 solutions on a graph, on a parabola. You can cross the x-axis twice. You can have 1 solution, or you could have no real solutions. Okay. The next lesson, we're going to look at ways to find these solutions without actually graphing.